Okay, so just something really basic that a lot of people forgot to go over that we need to add to our other screencast is when you look at the torque and arc length graph, you basically are looking at the same graph that we looked at when we were first learning about spring constant. Originally, we had a change in x on this axis and a force on this axis, which is basically what we have here. We have arc length, which is just like change in x, it's a length that's changing over, well, it's our independent variable, so we're changing it to measure a force that's put on our object, or in this case, like for a spring, we have torque. But originally we just called it force, and it's measured in newtons. So we even have the same units that we originally work with, meters and newtons. So when we get our equation over here, torque equals 35.65 n over meters times arc length, whatever. Basically, this slope right here is our spring constant. Like in a problem, if they said k equals 35.65, that's what it would look like this. And that's because that's the rate at which this spring requires energy, I guess you could say. So for every meter you want to change the arc length, or in how you originally learned, every meter you want to pull the spring, you need to you're going to need 35.65 newtons of energy. So your spring constant could be something else. Like if we got 40, the slope of this graph would be 40, and then our spring constant would also be 40. So that's how spring constant looks, and that's kind of where we get it from.